Chapter 4 is probably the heart and soul of this course, because in Chapter 4 what we talk about is factoring. Initially, what we're going to talk about in 4.1 is factoring out common factors and factoring by grouping. Then as we get into Chapters 4.2 and 4.3, we get into more sophisticated factoring. We use factoring then to solve problems in Chapter 5 and probably even some of the problems later on in the book. So let's start by talking about how do we factor out what's called a common factor. Got a pretty simple example here with number 22 where it says 5x minus 15. Is there some number that divides evenly into the first and the second of the two terms in our binomial? And obviously the number is 5. So what I can do is I can factor out that 5, and what I get is x minus 3. And of course, if you multiply through, 5 times x gives you 5x, 5 times negative 3 gives you negative 15. You know that it works. Jumping over to number 28, now what I have is what number divides evenly into 12 that also goes into 6, and that's pretty obvious. That's the number 6. But because I have a y squared in the first term and a y in the second one, I have y available in both terms, and I can pull that y out of there too. What does that leave me? If I take 12y squared divided by 6y, what I have left is 2y. And then if I take a negative 6y divided by 6y, what I end up with is just negative 1. And if you multiply through, you'll find that that works. Now looking at number 44, I've got, wow, lots of terms. I've got a polynomial with 4 terms in there. What's the largest number that divides evenly into all of those numbers? And that number turns out to be 8. So we're going to factor out an 8. But if you look, you also have p taken to the 6th power all the way down to p squared. The lowest power that we have available to us is p squared. So I can pull that out, p squared. What I'm doing now is I'm dividing each one of those terms by 8p squared. So our first term, 8 divided by 8, just gives me 1, and p to the 6th divided by p squared gives me p to the 4th. The second term, 40 divided by 8, gives me negative 5, and p to the 4th divided by p squared are p squared. In the third, 24 divided by 8 gives me 3, and p cubed divided by p squared gives me just p. And in the last term, negative 16 divided by 8 just gives me negative 2. And because p squared divided by p squared is 1, we are done. You may want to check that out. Now we're going to talk a little bit about factoring by grouping. And number 50 is a good example of how this works. Notice that in our 2 terms, and we only have 2 terms, we have a common factor, but instead of being just a number or a letter, it's that binomial b minus 5. I apologize for that. So we pull that out, and what we have left now is b plus 2. And whether you multiply across, with the original problem is written in number 50, or whether you FOIL our answer, what you'll get is b squared minus 3b minus 10. That's when you multiply through and combine like terms. So that shows that we can pull out not just a number or a letter, but we can also pull out a binomial. That leads us to the idea of factoring by grouping. And we're going to use factoring by grouping when we solve some of the more sophisticated trinomials a little later. We'll talk about that later. In factoring by grouping, what we want to do in this first case with number 54 is we want to separate this into 2 groups. All right? 2 groups of 2. Taking a look at that first group of 2, we have x cubed minus 6x squared. What's common to both of those is the highest power of x, which is x squared. And what we have left then is x minus 6. What we have in our second term, however, we don't have an x in both of those terms. All we have left is 2. That's common to both. So if I pull 2 out, what I end up with is x minus 6. Now we have that common binomial in both of those terms, x minus 6. And we're multiplying that by what's left, x squared plus 2. All right, let's move down and take a look at problems 60 through 78. Looking first at number 60. We have x cubed minus 4x. And we're going to break this into 2 parts. Again. I'm sorry. I meant to do that in red, but that's okay. That first part, x cubed minus 4x. All right. What we can pull out of there then is just x. And what we have left then is x squared minus 4x. I may have copied that incorrectly. Let me see about that again. This is number 60. Yeah, that's supposed to be 4x squared. So let's go back and start this over again. Because now the biggest thing we can pull out of there is x squared. And what we have left is x minus 4. That makes this problem work. What we can pull out of the second term is just 2. And what we have left is x minus 4. Now we have that common factor, x minus 4, and what we have left is x squared plus 2. Now, number 66 is there for a purpose. Number 66, what we're trying to do is pull out a common factor, but because that first term is a negative 6y to the 5th, we want to make that first term positive. So what can we pull out of that? Well, a number common to all of our numbers, 6, 9, 18, and 12, happens to be 3. And I'm going to pull out 3, but I'm also going to pull it out as a negative 3. What that does is it changes the signs for everything we have in there. So now this becomes 2y to the 5th. This becomes a negative 3y cubed. This becomes a negative 6y, and that becomes a negative 4. And when you multiply by negative 3 through all those terms, you'll find that that works. You're saying, well, why do we do that? Because if we're going to do factoring by grouping, as we're going to do with numbers 74 and 78 here, what we want to do is now take a look at pulling out a negative factor. So let's just take a look. Right here, we're going to split this right there. Let's take it the first term. In the first 2 terms, we've got common to both of those just y. We don't have x's in both terms. We don't have numbers in both terms. All we have is y. What do we have left? X minus 5y. All right? And what we have left is negative x positive 5y. Well, that doesn't really work for us, but if we pull out a minus 1, now this becomes x minus 5y. And now we have that common term, x minus 5y times y minus 1. Now, this last one, number 78, this one is very, very challenging. We're going to go through and take a look at it because in this particular problem, first we're going to pull out common factors, but then what we have to do is we have to rearrange the terms to group them that in places where they belong together. All right, let me explain what we're talking about here. We have p to the 4th in the first term, p cubed in the second term, p cubed in the third term, and p squared in the 4th term. That's the only thing that we have common to all 4 of those terms. Because we don't have any q's in the first term, we can't pull out any q's. There is no number that we can pull out. So what we have is we just have p squared. And then we have 2p squared plus 3p cubed minus 2p cubed minus 3q squared. That's interesting, but it's not terribly helpful yet, because if we break it into the first two and the last two, we're not going to end up with what we want. I don't think. Let's just take a look. If we happen to rearrange this so that we put the 2's together and the 3's together, this might help us. So what I'm going to do is I'm going to take and let's pull out in those first two terms a p. And we have left is 2p plus 3q. Now looking at the last two terms, what can we pull out of that? Well, we can pull out a q, but in order to get the pluses there, what we have to do is pull out a negative q. And what we have left then is 2p minus, or plus, I'm sorry, 3q. So now what we've got is we've got a common term in there, 2p plus 3q. It's common to both. So we didn't have to regroup these. I thought we might, but we didn't have to. Now what we've got is 2p plus 3q times what's left, which is p minus q. So there's that problem. If you can solve a problem like that, you should have no problem with factoring by grouping.